back to Vidyanagar online science class. Today we are going to discuss about our first physics chapter, chapter 8, motion. At the end of today's class, you will learn about motion, different types of motion, distance, displacement, uniform motion and non-uniform motion. Let's begin today's class. Okay. When we look around us, we can see different types of objects. Some objects are in motion, some objects are at rest. Like birds fly, vehicles move, fish swim, etc. always moves. And objects like stone, desk, bench, etc. always at rest. So, in today's class, mainly we are going to understand what is a motion, how to give a definition to motion, what is exactly a motion is. When an object changes their positions with respect to time, it is said to be in motion. If an object changes their positions according to time or with respect to time, it is said to be in motion. For example, now I am moving forward and I am moving backward. So when I moved forward and when I moved backward, I changed my positions. I changed my positions according to time, which means I am in motion. Okay, now I am moving. So what is a movement or what is the meaning of a motion? If an object changes its position with respect to time, it is said to be motion. For example, see, a car moves. Car changes its position according to the time. When the car is at rest, is it changing their positions? No. So in that case, car at rest. If the car does not changes the position, car is at rest. If it changes its position, it is said to be in motion. So generally, if an object changes their position with respect to time, it is said to be in motion. If it does not changes its position according to the surroundings, it is at rest. So, which is the simple and finest definition for the motion? If an object changes their positions according to the time or with respect to the time, it is said to be in motion. If an object does not changes its position according to the surroundings, it is said to be at rest. So, if an object changes their position with respect to time, it is said to be in motion. If the object does not changes their positions according to the surroundings, it is said to be at rest. Moving car, in motion. The stationary car, at rest. So if an object changes their positions with respect to time, like now I am moving forward and I am moving backward, so I am changing my position, which means I am in moving condition. Just like if an object changes their positions according to the time, it is said to be in motion. If it does not changes their positions according to the surroundings, it is said to be at rest. Okay, and you have studied from your previous class or from the last year classes that motions are of different types. There are different types of motions like straight line motion, circular motion and periodic motion. So which are the three types of motion? Straight line or rectilinear motion, circular motion or periodic motion. If an object moves in a straight line, such type of motion are straight line or rectilinear motion. If an object moves or if an object travels in a straight line, it is said to be in straight line motion or rectilinear motion. For example, motion of a car on a straight road. So the object or the car moves in a straight line. Such type of motion are straight line motion or rectilinear motion. And you know, motion of a fan, circular motion. Rotation of the fan, that is circular motion. Why? Because fan moves in a circular path. So if an object travels in a circular path or moves in a circular path, such motion is said to be circular motion. Motion of a fan or rotation of the fan, etc. examples for circular motion. And the next one is periodic motion. Motion of a pendulum. How the pendulum moves? Pendulum moves like this. First to there, to middle, and to there, and again back to the middle. So such motion is said to be periodic motion. That is to and fro, here and there. To and fro motion of an object is said to be periodic motion, or back and forth motion of an object is periodic motion, like motion of a pendulum and hands of a soldiers of march past, right? So periodic motion. So if an object moves back and forth or to and fro, such motion is periodic motion. So straight line motion, object in straight line, movement in straight line. Circular, if it moves circular path, that is circular motion. And if an object moves to and fro or back and forth, that is periodic motion. Okay, now we are going to describe the motion. How to describe a motion? If you want to locate a correct, if you want to give a correct location to the object, if you want to give a correct location to an object, first you have to specify a reference point. You have to specify a reference point. For example, if anybody asks you, do you know where is Vidyanagar Public School? So it is the easy and convenient way for you to say to that person that our school or the Vidyanagar Public School is very near to the spinning mill. So spinning mill is the reference point. So it is a well-known point. So that is reference point. So if you want to give a correct location to an object, you have to specify a reference point. Like if you ask me, where is Preeti Silks? You can say it is near to the airlines hotel. Or where is Hairlines? It is near to the Preeti. So that is reference point. On the basis of a point or a thing, you can give location to the other objects. Like based on spinning mill, we can describe the position of Vidyanagar Public School. So that is reference point. So in order to locate an object, we need to specify a reference point. That reference point is the origin. If you want to locate a position of an object, we need to specify a reference point. That reference point is called origin. So in case of our school, spinning mill is our origin, or based on that we can give location to our school. So if you want to give a location to an object, we have to specify a reference point. That reference point is known as origin. So if you want to locate an object, we need to specify a reference point. That reference point is known as origin. Yes. Now we are going to discuss about distance and displacement. What are the differences between distance and displacement? First, we can define these two. What is a distance? Okay, we can understand this concept with the help of an activity. Right, look at the board. You can see rectangle ABCD on the board. What you can see on the board? You can see rectangle ABCD on the board. Okay, A is the starting point. What is A? A is the starting point and D is the finishing point. So A is the starting point or D is the finishing point. So for the starting and finishing, we can use other words in physics. Initial, starting, initial, and finishing, final. So A is the initial point and D is the final point. Initial means starting, okay, and final means finishing. Okay, so A is the initial point and D is the final point. Okay, so your task is to reach at D. Your task is to reach at D. There are two ways for you. Either you can go through the B and you can reach at D, or you can cross this A to D. Which is the comfortable way for you? Definitely now everybody is behind the shortcuts, right? So definitely I know you will cross the way A to D. So what is the difference between covering A to B then to D or crossing AD? A to B then to D is the distance, which means it is the total path covered by the object. A, first he or she need to start from the A, then B, then to D. So this is the total path covered. So distance is the total path covered by an object. Distance is the total path covered by an object is distance. And if you cover this distance A to D, this is the shortcut, right? So that shortcut is the displacement. Shortcut is the displacement. What is distance? Distance is the total path covered by an object, or it is the total path between initial point and final point. In two ways we can define. Either we can write it is the distance is the total path covered by an object. Total path covered by an object, or distance is the total path between initial point and final point. Then how will we define then displacement? This is displacement. Displacement is the shortest distance between initial point and final point. It is the shortest distance between initial positions and final positions. So what is displacement? Displacement is the shortest distance between the initial point and final point, or distance is the total path covered by an object. So what is the main difference between these two? Distance is the total path covered by an object, or it is the distance between or the total path between initial and final positions. Displacement is the shortest distance between initial and final positions. Clear? So I told you, you have to reach at D. Either you can cover A, B, then D, or you can take the shortcut. Taking shortcut is the displacement, or covering complete path is the distance. So distance is the total path covered by an object. Distance is the total path covered by an object, or it is the total path between initial and final positions. And displacement is the shortest distance between initial and final positions. Clear? So if a person cover complete path, that is distance. If he or she takes the short way, that is displacement. So distance is the total path covered by an object, or displacement is the shortest distance between initial and final positions. So this distance is, this path is the distance and this is the displacement. So total path covered by an object, distance, and shortest shortcut or shortest distance between the initial and final positions, displacement. Okay, and the SI unit of distance and displacement is same, that is meter. Which is the SI unit of distance and displacement? Meter. Distance is the total path covered by an object. Displacement is the shortest distance between initial and final positions. Both have same unit, that is meter. Clear? Now I am going to introduce two terms, new terms with you. vector quantities and scalar quantities. So these two quantities you will see in coming sections repeatedly. This is a very important point. Vector quantities and scalar quantities. Vector quantities are the quantities which have both magnitude and directions. Which have both magnitude and direction. And scalar quantities are the quantities which have only magnitude. Magnitude means number. For example, force, which is the example for vector quantity, force. For example, force. Force we studied last year, right? Which is the SI unit of force, Newton. Suppose an object exerts 2 Newton force. 2 Newton force to down or up, or to forward direction or to backward direction. So there you have to specify the direction, right? So if you specify the direction only, it will be meaningful. 2 Newton force. Simply if you express that, it is incomplete. That Newton to where? Is it to up or down or side or back? So it's an incomplete situation, right? So with that, if you specify 2 Newton force to forward direction or backward direction or down or up. So if you specify that 2 Newton or any number with the direction, it will be complete or meaningful. Such quantities are known as vector quantities. If a quantity have both magnitude means what? Number 2. The 2 is the number, right? So if a quantity contains number as well as directions, vector quantity. Like 2 Newton force to forward or backward direction, their number as well as direction. Right? And weight. Weight means, for example, a person's weight is 50 Newton. 50 Newton. Right? So our body always exert force to down. Now I am standing now. My body exert force to downward direction. So there also direction is there, downward direction. And for example, 60 Newton to down, number plus direction. So if a quantity contains both number and direction, they are vector quantities. That is magnitude. So vector quantities are the quantities which have both magnitude and direction. And there are some quantities which have only magnitude. Like, time, 2 seconds, 4 seconds. So 2 seconds to north or 2 seconds to south, not now, 2 seconds. There you have to specify only the number. If you specify only the number, they are scalar quantities. If you specify the number or magnitude, they are scalar quantities. Understood? So if a quantity contains number plus direction, vector quantities. If a quantity contains only the number, they are scalar quantities. Scalar quantities. So what are vector quantities? Vector quantities are the quantities which have both magnitude and direction, like distance, velocity, force, etc. And scalar quantities are the quantities which have only the magnitude, like time, speed, only the number. You have to specify only the number, no direction. They are scalar quantities.
Difference between distance and displacement. Distance is the length of the actual path covered by a body irrespective of its direction of motion. Displacement is the shortest distance between the initial and final positions of the body in a given direction. Distance between two given points may be same or different for different paths chosen. Displacement between two given points is always same. Distance is a scalar quantity. Displacement is a vector quantity. Distance covered is always positive or zero. Displacement covered may be positive, negative or zero.
Now we are going to discuss about uniform and non-uniform motion. What is uniform motion? If an object covers equal distance in equal intervals of time, it is said to be in uniform motion. If an object covers equal distance in equal intervals of time. For example, you are planning to a tour, and at the starting, you covered 5 meter. Then in 5 seconds, 5 meter in 5 seconds, then you get out of the car and you watch the scenery, then you restarted the journey, then next 5 seconds you again get out of the car, and this continues, right? So in these each gaps you can see 5 meter 5 seconds, 5 meter 5 seconds. So distance and the time same. The both numbers are same now. If it is 10 meter 10 seconds. Okay, so if the distance and time same, such type of motion is known as uniform motion. That is, if an object covers equal distance in equal intervals of time. What is uniform motion? Uniform motion is a motion in which if an object covers equal distance in equal intervals of time, it is said to be in uniform motion. If an object covers unequal distances in equal intervals of time, time interval same and distance like 5 or 10, 20, etc. If the distance changes but the time gap is same, such motion is known as non-uniform motion. So if time gap and the distance same, uniform. If means time gap same and the distance different, non-uniform. If an object covers equal distance in equal intervals of time, uniform motion. If an object covers unequal distances in equal intervals of time, non-uniform motion. If an object covers equal distance in equal intervals of time, uniform motion. If an object covers unequal distance in equal intervals of time, non-uniform motion. If the time and distance same, uniform. If the time gap same but the distance is different, non-uniform motion. If an object covers equal distance in equal intervals of time, uniform motion. If an object covers unequal distances in equal intervals of time, non-uniform motion. So this is the conclusion of today's class. Watch the video carefully, understand the concepts. We will meet you soon. Until then, it's bye. Thank you for watching. Have a nice day.